blob of storage. And here's some of the things that we encounter. So, if we have a noisy neighbor or some performance spikes, I mean, you have a user that starts reporting 10 milliseconds of latency on an all-flash array, and you're like, well, I don't understand who's causing that. Well, it's really hard to figure that out when you have 1,000 different VMs running in a single LUN. I mean, how do you do that? There have been lots of tools created to kind of help manage that and probe into vSphere and all of the metrics and kind of figure out, help you track that down. But at its core, VMware doesn't have a mechanism to really track everything on a one-to-one basis, not from the VMFS standpoint. So what do we do there? Well, with Noisy Neighbor, right, there are tools, but you have to lay them over top of vSphere, kind of investigate. It's not terribly straightforward. Another thing that and this is what I've talked about, right, we don't have any VM to storage visibility. If you have 4 or 5 volumes attached to a guest, and there's a performance problem, which one's doing it? Is it something there? Is it the storage? It's just really hard to figure out. And then something we don't really think about is what we've called here compliance drift. So suppose I have an SLA, or probably most notably a replication scenario or a DR strategy assigned to one VMFS. And then through the beauty of storage vMotion, that those guests get moved to a different storage data store, and now they're no longer compliant, right? They're no longer being replicated to site B. What happens? How do we figure that out, right? Traditionally, I mean, I was a VM administrator for a long time. I started using VMware in 2000. And did it for a long time, right? Spreadsheets, kind of the traditional thing to manage this. So this was sort of the problem that VVols looked to address. How do we make storage more granular, back to the days when it was a one-to-one physical relationship? So what is a virtual volume? Well, a virtual volume is a disk, is a volume for every virtual volume that's attached to your guest. How does that sound? So think about it. You can kind of think about it as an RDM that's got a management layer through vSphere around it, right? So you have virtual disk granularity for every guest in your environment. So what does that give? That allows us now to use array-based technologies to manage our virtual volumes, because they're not actually virtual volumes anymore. They are physical volumes sitting on your storage array, and you can use all of the storage features because every LUN is mapped directly to a drive letter or a mount point in your guest. One thing I wanted to kind of set the stage for as well is I will talk about some Pure and flash array specific stuff in here, but for the most part, this goes for most of the major enterprise grade storage vendors out there today. The feature functionality may vary from one to another. I can only talk about what I know from a storage standpoint, but for the most part, you should have fairly parity functionality in your arrays. Any questions on this? Okay, so another very cool thing, and we're going to get to this at the end of the show, is storage policy-based management. And I'll talk about that more when we get there. But this is something I think that's really been missing in the virtualized environment. Is we focus a lot on the hardware. We focus a lot on arrays, and what we really need to focus on is the capabilities that we want out of those arrays. It's not so much the, do I want SSD, or do I want spinning drives, do I want replication? It's, do I want my stuff protected? Do I want it replicated? Do I want it sent to a DR site? Those sorts of things. It's more about the services than the actual underlying hardware, and the storage policy-based management, or SPBM, is what's going to give us that. It's kind of cool. We'll get to it in a little bit. So, virtual volumes, how do they work? Well, There's a couple different elements. There is basically a vendor provider of the VASA, which is a VM API storage awareness provider that sits out there and tells VMware what kind of services are available. Okay, this says we'll get into what the VASA provider actually presents a little later on, but this is the mechanism for the control or the management path. Okay, so that's the first element. The second element is what we call a protocol endpoint. This is what VMware calls protocol endpoint, and that's going to be your data path. So all of your data is managed through the PE, and all of your mounts and everything go through this PE. That PE sits on your storage array and manages the guest to storage relationship. And then you have your admins who can administer storage policies, capacity, and those sorts of things. This actually lets us sort of divide those tasks up. So if you want to offload some of the storage policies to your backup guys and have your storage guys be responsible for capacity and managing the physical storage itself, right? You now have the ability to do that. This is, again, a big picture. We're going to dive into each one of these elements very quickly. So, what is it? So, every virtual machine has a number of individual volumes on the array. This is kind of cool because now my guest is going to have a number of physical volumes that sit on your array. There's a config volume, which it's a 4 gig basically descriptor file. It holds a configuration of the VM. It's created automatically when you bring up a host. It's not something that you have to manually create. By default, it's 4 gig. You have the option to make it 8 gig. No real reason to do that. But it's just really a placeholder. Then you have your data VVols. So for every drive letter, in the Windows case, right, you'll have a C drive and a D drive or an E drive, whatever that is. Those are going to be data volumes. There's going to be one volume on your array for every drive letter that you create, again, in Windows. This doesn't just work for Windows. It works for Linux or whatever operating system you want to run within VMware. You also have a swap volume. This is going to be equivalent to the size of your memory for the system. This is kind of a standard VMware construct, no different than what you have today in a VMDK environment. The difference is instead of being a file sitting on that VMFS, it's going to actually be a volume on your array. And then lastly, there's a memory VVol. So if a snapshot's taken and by default, if you choose the snapshot memory option, it's going to create this LUN very quickly. And that's going to cache your memory so that when that VM's restarted, it's in that same state. Any questions about that? What I'm telling you here is if you create a guest with a single volume attached to it, there will actually be 4 volumes created on your array. Okay? So if you had 100 virtual machines, you'd have 400 LUNs on your array, 400 volumes. Okay. What that gives you is immense granularity, right? I can have replication, I can have QoS. We'll talk more about this. I can have different policies assigned to these different LUNs and get very granular with what I do with each one of them. And I don't know if you can see that. I guess you sort of can. If you can see this here on this VM, here's my config. This says config, and it's got a unique identifier, data, and swap, right? Those are just constructs that are created during the normal process of bringing up a guest. Snapshots. Who likes taking VMware snapshots, right? It's been a subject of a lot of discussion over the years. And by default, VMware snapshots are great, right? They allow you to quiesce the machine. They allow you to take backups. They allow you to sort of save a guest, apply an update to it if it works great, roll the snapshot back in, otherwise revert, right? It gave us a lot of functionality. The problem is they can impact performance, and especially if you start cascading those, and you get multiple snapshots, right? VMware itself, best practices, don't keep those snapshots longer than 24 hours, okay? But now, with VVols, snapshots are actually executed on the array. So every storage operation you do with a VVol is actually a storage operation using VAI to execute that operation on the array. There's no more Delta files to impact performance in your VMware environment. Okay, that is pretty cool. And if you ask me, that's probably one of the biggest benefits of running VVols, is being able to utilize your array-based snapshots for all the goodness they can provide. And you'll see here, little example. I've got an application, take a snapshot. What you'll see here and again, this is a pure array, you'll see the snapshot being created here. This is done for you. vSphere just makes a call to your array, and it happens. It happens there. Again, your provider may vary if you're not running Pure, but it's going to be most likely very similar. Any questions? Cool. All right. So why is this kind of awesome? Well, what did a VMDK restore look like? If you had to restore a single volume out of VMFS, how would you do that? Now again, storage-based snapshots are great, but they do require a little bit of work. Now, most of the backup systems that integrate with VMware and what have you automate this through a number of steps and scripts, and if you look behind the scenes, they're going to be doing these things. But basically, you've got to copy that snapshot to a volume, make it writable through whatever mechanism your storage array uses. You've got to connect that volume to the host. You've got to rescan, resignature that, delete the original one, copy your VM over, or copy your VMDK over, unmount, delete, and finally you're done. So that was a typical operation. We've become familiar with that. We've become comfortable with that. There's been a lot of integration and sort of operationalization of that process. And it's great that we have it, but what if it were different? Okay. So in a data VVol, I know that's a bad word, RDMs, but it basically is an RDM. It basically is a file, a volume that your operating system has complete control over, right? Whatever operating system, whatever file system you put on that LUN, that volume is what is on that. That is what that volume is. It's just a block volume. Whatever your guest puts on it, there is no VMFS encapsulation around it. There's no header. There's no trailer on it. It is basically a raw device map. Okay? So the nice thing about this is it's orchestrated through vSphere. So vSphere is going to control all of this operation. Now, what does that mean? Here's where it gets cool. What does a VMDK restore look like with VVol? So let's suppose that I've got a number of volumes here, and you can see I got my config and my swap. I've got a couple of data. I'm going to hit play on this VM. No, that's not this one. I'm going to take a snapshot of this E drive. Okay. Then I'm just going to copy that or revert that original volume to the snapshot. Right. Most of your arrays out there can take a snapshot and make it active, make it the active file system. That's all I got to do. Boom. I now have a restore point of that E drive instantaneously, all done through the storage. There's no copying from one data store to another, right? That takes time. This is instantaneous, or as fast as your array will perform it, which is usually seconds. But here's where it gets even cooler, right? And yet there's more. Because there's no VM encapsulation around these, you can attach these LUNs to physical or virtual machines equally. Okay? How cool is that? Well, let's suppose I have a physical SQL server, and I want to take the database and present it up to a VM, right? I can take that LUN on my array. I can make a clone of it. I can present it up to VMware with VVols and just attach it, right? Physical, virtual, it doesn't matter. VVols are simply an encapsulation of or a non-encapsulated file system. So what does that look like? We copy the snapshot over to the VM, and we're done. That's how easy it gets. I should say, of course, you could do it the other way as well. Suppose you had a DR scenario and you're running VMware in your production, but you had some older servers or whatever in your DR environment. Well, you could copy those over and mount those same volumes up to your physical hardware and have it available to you, right? Instant copies. So what about the data plane? Anybody who has kind of processed a little bit what I've said might be thinking, I hear what you're saying, Eric, but what you're telling me is for every VM, I'm going to have 4, 5, 6 arrays on my volume. Each one of those with a SCSI ID. I'm going to run out of identifiers pretty quickly. How do I manage that? I've got 500 VMs, and that could be several thousand volumes on my array. Yeah, well, VMware has created a concept of a protocol endpoint. So what this does is basically provides a conduit from vSphere into the array. So VVols they're not connected to a host in the traditional way. A protocol endpoint is basically just a mount point for all these VVols, and we're going to dive into how that looks here in just a minute. But it's presented in a traditional fashion, whether it's iSCSI or Fiber Channel, whatever you're running, and multipathing's the same. But the way it's handled on the back end is kind of slick. Okay, so protocol endpoints. Flash arrays automatically going to bind the VVols to the appropriate protocol endpoint. And then VVols appear as a sublun. Has anybody ever? I mean, if you've done storage for years, you probably use subluns, luns and subluns. Basically, what you do is you have a single LUN identifier, a single SCSI reservation, and then you have subluns behind it. Now, what that means is all the I/O goes through the PE, the protocol endpoint, and then the array has this set or this bit set that says I need ID 62, right? So everything comes down that SCSI channel. LUN 62 gets called for, and then the array provides data back from the appropriate address. In T10 or SCSI terms, a protocol endpoint is really just an administrative logical unit, right? This is what you know as your traditional SCSI ID. Virtual volumes then are your sublun or your subsidiary logical unit, and that is identified with this colon. So traditionally you'd have LUN ID 254, 253, 252, right? That would be the counter. We just put a colon as the sublun identifier after the ID, and that gives the array a map of where to go for this data. Now, we can have up to 16,000 LUNs, subluns per LUN ID. So that's a lot. So even if you have 500, 1,000 VMs on your array, you're probably not going to exceed the capacity of a single endpoint on your array. You can have multiples if you like. You probably won't need more than one. If you need 16,385, it's time maybe for another protocol endpoint. Any questions? What's that look like? Well, I kind of explained that, right? So the VM is going to go through ESX. It's going to go to what it thinks is LUN 10, SCSI identifier 10. Once the VM is powered on, like we talked about earlier, this swap LUN is created, the swap volume is created. That volume is actually destroyed when the VM is powered off, just as a side note there. And then we're going to attach to LUN 10. All these are LUN 10, but sub-LUN 1, 2, 3, 4, whatever it is. Okay. If one of these volumes gets moved through storage vMotion or what have you, it simply goes to the new protocol endpoint or the same protocol endpoint somewhere else, however you're doing it, and it gets a new LUN ID and sub-LUN identifier, right? The nice thing is vSphere does all this for you. Your array, your and vSphere work together to provide these services. Not something you have to manage or worry about. This is just sort of under the covers. Right. So how many PAs PEs do I need, right? Depends. One common concern you have or you hear about VVols is, well, I've got all this I/O going through a single SCSI ID. How is that going to affect my performance? What might I need to do? By the way, we create a PE by default called Pure Protocol Endpoint. That's just done for you, single one. Most likely, I mean, at this point, what you see is the flash array or storage array becomes the bottleneck, not the PE itself. And the reason for that is really about queue depth. Okay, so the default queue depth for VMware is what, 32. That when you bring in VVols, that queue depth is increased to 128. Now, queue depth says how many outstanding IOs can I have, and if you think about an all-flash array delivering, half millisecond response time, right? That means that in a second, which is 1,000 milliseconds, I can provide about 2,000 IOs, right? So, and that's with a queue depth of 1, right? If I have a queue depth of 128 or even 32, right? That's 64,000, 65,000 IOs I can do with just a queue depth of 32. Increase that to 38, that goes up to 256. That's a lot of I/O, right? Your array is probably going to be your bottleneck at that point if you're pushing that kind of I/O. So that's from a queue depth standpoint. You can also increase that all the way up to 4096, which is something in the neighborhood of about 8 million IOPS. So might be looking at a new array at that point. Any questions? So the management plane, the VASA provider. What does that actually do? What does that look like? How does VMware manage the array? Well, the VASA provider is offered either on the array, in our case it's on the array, or a VM. The challenge with it being a VM is if it's a VM and it's running in a virtualized environment and you're running VVols on your virtualized environment and your VASA provider is sitting on your VVols and they die, how do you start it back up? Because you need the provider to start them back up, but you can't start them back up without the VASA provider. So you have to do some magic and some shell game stuff. So in Pure's case, it runs on the array. It runs highly available, right? It started automatically on the array, dual controller design in our case. So, if the array is down, it doesn't really matter whether or not your VASA provider is running or not because you don't even have the storage. So, in that case, what you do is you bring the storage back up. Your VASA provider is restarted automatically. Now you have access. Now, you might be saying, well, hey, that VASA provider seems pretty important. What happens if it dies? Is all my I/O stop? Well, no, because this is a SCSI handshake, right? This is a SCSI transport. All the VASA provider is doing, just like vSphere, your vSphere interface. If your vSphere interface dies, right? If that VM dies, your virtualized environment doesn't stop, right? You just can't make changes to it. If a VM stops, you can't restart it, but your environment doesn't go south. So the VASA provider is the same way. You're not going to lose your lunch. You're not going to have any issues until you try to restart or something like that. So it's a stateless sort of provider, right? It's just queried. What are my capabilities? What are my features? And I talk a little bit about what that does in a couple slides. But the thing is, it's not critical to the daily operation or the constant operation of your volumes, right? It's just out there providing basically a service catalog. Okay. Like I said, on flash array, the VASA provider runs on the flash array, active. And when you install a version of Purity that supports VASA version 3, it's started automatically, so you don't even have to worry about it. Now, VASA versions in vSphere 6, I believe, they introduced VASA version 2, which provided a lot of the functionality we have in VVols today. VASA version 3 includes replication. That's kind of the key, right? That gives you sort of not just your local, but also the ability to look at replication and manage that through VVols as well. That is, we're going to see that in just a little bit with our service categories in just a little bit. It's why that's important, why that's very cool. We run VASA version 3. That's available as of 6.5, I believe. And it just keeps getting better in subsequent versions of vSphere. So I've just told you really VMFS doesn't exist anymore. You don't need that in the VVol world. You don't need that for VVols. So what do you provision from? How do you create these VVols? This sounds complicated, Eric. How do I do this? I'm confused. Well, you actually provisioning from a data store. So if you look at this, I don't know if you can see this in the back, but when you create a new data store and you've got VVols available to you, you have that option. I can create them from a VMFS, NFS, or a VVol Datastore. It looks just the same. That's the beauty of VVols and what VMware has done here. Basically, you're putting them in that VVol container, and it looks like it always has. But it's important to know here that VVol is not a physical entity. It doesn't have any mass. Okay, it's not a LUN, a file system, a volume. It's a quota. It basically is a large pool or a collection of configuration files. So again, if you have 500 VMs running, you're going to have 500 volumes that are those configuration files. That's what you can sort of think of your VVol as being. It is a quota. It's just a management entity, right? So it doesn't have any mass. And on Pure default, and Cody set this up, by default, when you create a VVol Datastore, it's 8 petabytes in size. So it should keep you from having to do growing of your data store for quite some time. I mean, if you exceed 8 petabytes, it's probably time for a new one. But you can actually expand that. The vSphere limit for the size of data store, VVol Datastore, is 2 to the 64th. So that's some number with a zettabyte at the end of it. I don't know what is 16 zettabytes, I think. So it can be very, very large, right? So as much as your array can physically handle, you can present that in terms of VVol Datastore. And this is what it kind of looks like. This construct gives you the ability to traverse all of these in the way you're familiar with. This looks like a VMFS data store, right? You can traverse these directories, and if you hop into this directory here, right, you're going to see this config vol. You're going to see that virtual swap file running, the NVRAM, right? All of that stuff is there just like it always has been. It looks exactly the same. This is what VMware has done to encapsulate and make this VVol construct very easy to use. Questions? Okay. So I mentioned a little bit earlier that the VASA provider is basically an index or a card catalog or whatever you want to call it of information about your storage array and what it can do. And really, that's what it is. So, I mean, stuff about your volume configuration, block size, snapshot, replication capabilities, consistency groups, right? All of that stuff gets put in that VASA provider, and that's presented up to vSphere that this array has these capabilities. I mean, it could be anything, right? It could be orange, because that may make sense in that array's world. I don't know. But it is completely dependent on the storage provider. Now, I've talked a lot about the replication, why that's important. Talked a little bit about storage policies. Well, you know, we've always been really tied to the physical hardware that sits in our data center, right? This is my all-flash array. This is my large long-term retention array, right? We've always been very focused on what the array was and what it could do, not necessarily looking at it from a capability standpoint. Not this array is very fast. It's right sub-millisecond. It has replication to my DR site. it's on the good WAN link, whatever that might be. We don't really look at it that way. We have to kind of manage that in our heads. But what if the array could tell us it could advertise what capabilities it had? I would specify that those capabilities had to be present for my volume, and then the vSphere would go out and find those and just assign them for you automatically. Not only that, but it would tell you after you've assigned them if anything had changed, so that now you no longer are in compliance. Well, that's what I can now do with storage policy management. So in this case, I might want to add a rule for my VM that says, it has to be replicated, every hour and keep for a day, right? That could be a policy I assign to my environment, and I want to make sure that these LUNs, these volumes, are compliant with that, right? I can simply assign it to that. I'm choosing a policy, not a data store. That's really what I'm interested in, is what services do I need to operate my business, not what array I'm on, right? That's kind of next generation thinking in my mind, okay? The nice thing is, when you start filtering out or providing capabilities to your array, VMware is going to filter out the ones that don't meet your criteria. And if there's none, you're going to have to change your criteria or go into non-compliance for that particular LUN. Okay? You can see here that these compatibility checks completed for that particular volume, right? So it's going to check for you, and then it's going to tell you when they're out of compliance. On sort of a larger scale, what does that give you? Well, now I have very, very granular information about my storage performance, your data reduction ability or capabilities, what you're getting from your data reduction. I can get down now to this individual volume. So when I have a performance issue, or when I want to know that one volume's taken up a lot of space because somebody's dumped all of their photos of their dog in some directory, right? I can kind of narrow that down. And this gives you that granularity both for reporting and performance and replication, disaster recovery, business continuity, whatever term you want to apply to it. You can now see it in the same way you could with a physical server. Of course, in our case, if you want to look at the performance of an entire VM, we can now do that on a LUN-by-LUN basis. Little plug here for VM analytics, right? This is included in Pure One, and this gives you the ability to look end-to-end, all the way from your VM through to the storage, all based in our cloud. Again, VVols give you the ability to get very granular, very specific about that. Cloning, again, we get to leverage the ability of your array for clones, right? So you want to create a clone, simply ask VMware to create a snapshot. That clone is created. It happens instantly. There's no overhead. There's no Delta file. It happens instantly. 50 gig, 50 terabyte virtual machine, right? Pointer-based snapshots. We're only copying metadata, a few megs, right? It happens instantaneously. You can do all of that now very easily. Virtual restore, same situation, same abilities. One of the neat things that I like about Pure is we have recycling bin, if you're familiar with that. So if you do delete a volume or a snapshot, it actually stays in the recycling bin for 24 hours before it's permanently eradicated. So if you have an uh-oh moment, you do have a backout. And again, you have this ability now with VVols at a very granular level. Cody tells a story. This is kind of neat. We had a client who migrated from traditional VMFS to a VVol Datastore, and one of the features of that is you now get the in-host unmap of released blocks. So if anybody's familiar with that, as Windows or your operating system writes, it may free blocks. Your array isn't familiar with what the guest has done. There's been no communication up until now without some fancy scripting and some abilities, right? This is inherent in VVols. So when you move to VVols, all that space that's been freed up by the guest is now reported and freed up on the array as well. So in this case, it's kind of neat. Your mileage may vary. They went from 30 terabytes used to 20 terabytes used just by migrating from VVols. Now, talked about compliance checking. This is what that would look like. If you have a disk that violates, is no longer being 1 hour replicated, you're going to see this in your in vSphere, right? vSphere is going to tell you when you're out of compliance, when you're not meeting your business needs. I'm going to run through this. Kodi does have an Orchestrator plugin that you can download off the marketplace on the VMware marketplace. That will let you perform operations like test your failover, right? You push a button, you can test the failover of a VM on your remote side. Migration, disaster recovery, right? All of this is integrated through APIs into the storage and is all done through VRO. So that's available for free. It's built for Pure, but for the most part, it's ESXi commands. You can modify it for your own storage system if you were not running Pure, but it's kind of neat. Okay, so a couple caveats. SRM does not currently support VVols. So if you're using SRM, VVols are not a construct of that today. It's a priority. They're working on it. It will be available at some point in the near future, I believe. Oh, I missed that. So, maybe saying, Eric, this sounds great. Sounds like a lot of work. How am I going to get there? Well, storage vMotion. So, to move your existing environment from VMFS into a VVol environment, you simply create your VVol Datastore, do a storage migration, and now your VVols are created for you automatically. If you want to move back from VVols to VMFS file system, you simply do a storage vMotion from VVols to your traditional storage system. It's that easy. You can do it in a matter of however long it takes you to copy from one to the other. Both ways. Okay. So, in general, configuring VVols, fairly easy. You've got to register your VASA provider, right? So you have to tell VMware, point it to your array. The VASA provider will talk. Connect your protocol endpoint. That's a one-time operation. You create that PE. Mount your VVol Datastore. That's a one-time operation. And then migrate your VMs. Now you're running VVols. Okay. So you can obviously create and do your policy building later. And that's what it looks like, guys. I mean, that's the long and short of it. It's for me, it provides a lot of granularity. It provides a lot of functionality, especially in databases and things where you're doing clone refreshes and what have you. But it also, I think, simplifies our life in terms of troubleshooting and understanding what our VMs are doing on our storage arrays. That is the bulk of what I have. Are there any additional questions? Right? Anybody have anything they'd like to say or ask me? It really gets rid of a lot of this stuff. I mean, it goes on, but if you didn't have to think about this anymore, that'd be kind of nice, I think. So, SRM coming soon. Also, VM Cloud will soon support VVols in AWS. And currently doesn't support NVMe if you're running any of that, direct attach from your ESX NVMe over fabrics to your storage.